This talk is entitled Aether in Einstein's 1905 Special Relativity paper. First of all, it's all arguable, as per usual when talking about physics. This talk is based on what has come out from arguing with others. We go back to the usual translation of Einstein's 1905 paper on special relativity. It was entitled On the Electrodynamics of Moving Bodies, and this is the article here, published in 1905. So I'm not going into issues such as it might be a bad translation, and the article says the introduction of a luminescence ether will prove to be superfluous, inasmuch as the view here to be developed will not require an absolutely stationary space provided with special properties, nor assign a velocity vector to a point of the empty space in which electromagnetic processes take place. It's not really clear what that's supposed to mean, but it's usually interpreted as meaning there is no ether, or at least there's no ether in the context of special relativity. What would be good is if Einstein explicitly stated what the maths for ether was as contrasted to maths without ether, but unfortunately he doesn't do that. We're trying to make sense of Einstein's paper on special relativity. There arises lots of things to argue about because he leaves things unclear. The maths that I want to deal with from Einstein's paper is highlighted here, and you've got the equations are t subscript b minus t subscript a equals r subscript ab divided by c minus v, and an associated equation. But first we want to deal with what is said before that equation. Einstein is considering the length of a rigid rod, and says all these things here. I don't want to read it out too much, but basically he has a rigid rod and he's considering light going from one end of the rod to the other. And he then goes on to say the length to be discovered by the operation B we will call the length of the moving rod in the stationary system. And he goes on to assume something, and what he assumes that the length ... and eventually he's going to drop that assumption. When he drops that assumption, what Einstein seems to be doing is constructing a math equation of length of the rod, L, and that's lowercase l, which looks like a 1, as the length of the rod, r subscript ab, multiplied by a relativistic factor. And that is what leads us to the maths I want to deal with. Einstein says all this. We might imagine further that at each clock there is a moving observer, and that these observers apply to both clocks the criterion established in section 1 for the synchronization of two clocks. And he goes on then to give these equations. So when Einstein is dealing with these equations, he must be getting them from Newtonian physics, because they don't have the relativistic factor that is to be added later. Now, with Newtonian physics, there is two versions of Newtonian physics. there is Newton's particle or corpuscular theory of light and Huygens wave theory of light. So here it is, it's Newton versus Huygens, and there's a great deal written on this, and Einstein, as per usual, is not going to give sufficient detail in how he's thinking about these things in his special relativity paper of 1905. In fact, Einstein is going to totally omit mentioning whether he's using Newton's particle theory of light or Huygens wave theory of light. It's just that Einstein says ether is superfluous, so that would make one think he isn't using the wave theory. But now let's work out the maths for these two theories. Well, it's going to get a bit complicated. First, deal with the particle-like situation. So here we have a rod with endpoints A and B. Light leaves endpoint A to go to endpoint B, and the rod is moving with speed v in the same direction as the light, which is moving with speed c. So the light is the yellow coloured arrow, and the rod is moving with this in the same direction as the light. But when the light gets to endpoint B, the rod has moved from where it originally was at the time that the light left point A. So we need to start labelling a few positions. So the rod has endpoints A and B, and the light leaves the endpoint A when it's at position A subscript O, and during that the endpoint B is at position B subscript O. Light reaches endpoint B when the rod has moved to position B subscript 1. So the light has moved from A subscript O to B subscript 1. Something similar occurs on the return journey, and the return journey is this. The light bounces back from position B subscript 1 and gets reflected back to endpoint A. Light on the return journey reaches endpoint A when it's at position A subscript 2. So need to write the equations for all of this. So I have to do the Newtonian calculation for the light particle, and so let us say A is originally at the position A subscript O, and B is originally at the position B subscript O. So light goes to the right direction from A subscript O, and B will move from B subscript O to a new position B subscript 1 further to the right. Thus light travels from A subscript O to B subscript 1, and the time for this light for the light to do that is T subscript B minus T subscript A, i.e. light leaves A subscript O at time T subscript A and reaches B subscript 1 at time T subscript B. So time from A subscript O to B subscript 1 is T subscript B minus T subscript A. and so we can form the distance from that for what the light has travelled. If B had stayed at B subscript O, then the distance would be from A subscript O to B subscript O, and that would have given the equation there of just C times the time interval of T subscript B minus T subscript A. But light has moved a further distance, which is from B subscript O to B subscript 1, and that is the velocity v times the time interval. So we can form the equation for the length of the rod R subscript AB. And as a reminder, Einstein never explained any of this in detail in his special relativity paper. The return journey is from the times T subscript B to T A subscript dash, and you note the use of the dash. So the time interval is T subscript A dash minus T subscript B, and from that we get the C minus V all times the time interval. The rod length is then R subscript AB, and that is C plus V times the time interval T subscript B minus T subscript A. And from the return journey you also get the distance, and that is C minus V all times T subscript A dash minus T subscript B. Next you need to do a Newtonian calculation for light wave, and now with that we have an ether frame. Waves have a medium, light is a wave, so must have a medium which is called ether. The Michelson-Morley experiment was trying to measure light speed relative to an ether frame, and was treating light as a wave as per Huygens theory. So instead of a particle you have a wave, and I've shown the difference here. You've got what looks like a dot moving along, or you've got a wiggly line moving along. So for the wave we need an ether frame. Let's denote that as from position A subscript O, i.e. light is moving relative to that. Light moves from position A subscript O to position B subscript 1, and light moves with speed c, and it takes time t subscript b minus t subscript a, and the distance travelled is A subscript O to position B subscript 1, and that is c all times the time interval t subscript b minus t subscript a. And now the rod length is R subscript AB, which is position A subscript O to B subscript O. So you have to subtract V all times T subscript B minus T subscript A from the C all times T subscript B minus T subscript A, and that will then give you the length of the rod R subscript AB. Similarly, you can do it for the return journey, and it gives that equation for the rod length. So there's two ways of doing the calculation. You can do the rod length without ether, and it gives those two equations as in case I, or you can do the rod length with ether, and it gives those equations in the case of I I. Now you should take note that the letters in both these cases are referring to different things, so you shouldn't mix these two sets of equations. And we need to contrast that with what Einstein gave. So back to Einstein, he gave these equations. We can rearrange these equations in the way shown, where rod length r subscript ab equals c minus v all times the time interval t subscript b minus t subscript a. And you also get the equation for the rod from the return journey, and that's the rod length with the aether. So that's the case I instead of the case I from earlier. Einstein's math is based on light wave, which is Huygens theory, and not on the particle light theory. So Einstein does a calculation to get rod length based on using ether. He seems to say there's no ether, but he uses ether anyway in his maths, and there's at least two possible ways to look at this. First way is Einstein is mistaken when he says no ether, or interpreted to say no ether, and really his theory has ether. Second way, Einstein is bad at maths, and really he has no ether, as he seems to claim, so his maths needs amending. Now, a reminder of Lorentz's theory. Lorentz has the same maths as special relativity, but Lorentz is keeping the ether. In order to keep ether fitting with the Michelson-Morley experiment, he was adding what has later become called the relativistic factor, and the way that it's often portrayed is Lorentz, who together and independently of an Irish physicist by the name of Fitzgerald, suggested the reason light waves travelling with or against the ether wind in the Michelson-Morley setup got to the receiver at the same time as those travelling an equal distance across it was that the Hall experiment apparatus mysteriously shrunk in the line of its movement by just the right amount to compensate for the ether wind effect. So basically Lorentz is trying to keep ether in his theory, but he's adding length contraction to keep the ether. So based on a straightforward look at Einstein's Special Relativity 1905 paper, Einstein has an ether frame, the same as Lorentz's theory, just Einstein seemingly confused things with his words when apparently he was discarding the ether, and he wasn't using the relativity postulate despite stating it. When you've got using a preferred frame, you're not treating all the frames the same. So bringing in an ether frame, you're not using the relativity postulate. But all this course is arguable because can keep making different amendments to Einstein to try to make sense of what he's saying. As some people argue that Einstein made mistakes in his maths and mistakes in what he was saying. Thus it becomes impossible to agree what is really meant by his 1905 paper on special relativity. That weakness is one of its greatest strengths, because it allows people to believe whatever they prefer to believe from it. So my final protest is modern physics is based on the work of Einstein, but the maths that Einstein originally presented does not make sense. The focus on the maths not making sense seems mostly ignored by the mainstream, and they just carry on regardless. But the dissidents seem to do the same in not wanting to focus on the maths. What it results in is the maths of special relativity gets adjusted. It's then not precisely defined theory. Can't then properly test a theory if it gets adjusted ad hoc. There is no point coming up with alternative theories to the mainstream when the maths that existing theory is based upon is imprecise. You need to sort out the mess in the existing maths before being able to offer alternatives. Else you just keep going around in circles. Thank you at the end.